Assalamu alaikum and very warm welcome to all of you. Today you are going to learn what is time reflection of the discrete time signals, what is time reversal, you understand what x minus n looks visually. So let's straight away start with the definition of reflection. A time reflected signal, also known as the time reverse signal, is a signal that has been flipped or mirrored along the vertical axis, because we are talking about the discrete time signal. So vertical, the x-axis in the discrete time signal is denoted by n, so we flip the signal around, along the n equals to 0. Mathematically, this operation replaces the independent variable time, which is n, by minus n. If the original signal is x of n, reflected signal is x of minus n. Because we are talking about the time domain signal, therefore I'll be referring to time, that means the discrete time signal or the continuous time signal. So signal flips around the vertical axis, n equals to 0. Positive side becomes negative side, and negative side of the original signal become positive side after the reflection, and you understand there is no change in amplitude. So let's have a graphical representation of reflection. So before we talk about reflection, let's have the look at the original signal. So you understand this is a discrete time signal. How do you know this is discrete time signal? Because the signal exists at a discrete interval of time. For example, it exists at 0, you understand, n equals to 0. Then it exists at n equals to 1. But it doesn't exist in between these. So hopefully that's clear. So the signal has value of -1 and -3 at 3, -2 at 2, -2 and -1 at 1, 0 at 0, and again +1 at index 1, +2 at index 2, and +3 at index 3. So its reflected version will look like this. So you see, in original signal, positive amplitude, this side is shown, the positive has the positive amplitude, and on the left side it has the negative amplitude. That means on the left side, amplitude as well as index is negative. On the positive side, the signal value and the index is positive. For example, this is +1, right? This is +2, +3, +4, +5, so on. You understand, right? So after reflection, because we are reflecting around this point, okay, so all those signals that are to the right will be the part of the signal, right, to the right will be shifted to the left, and all part of the signal that is to the left will be in the reflected will be shifted to the right. So that means the time reflected signal of this will be like this. So you see, the positive is shown by the blue color, whereas the negative is shown as the red color. So you understand, this part will shift to this side and this part will shift to this side. Like you are putting mirror here, so if you put a mirror here, from this side, if you see, this signal will be displayed here, okay. And similarly, if you put a mirror here and you look at in this direction, so this signal will be shown here. So this is how graphically time reflection looks like. So let's have its mathematical representation. So for example, original signal I shown you on the previous slide was x of n equals to n, and for valid interval for that was n equals to -3 up to 3. So sequence contains negative as well as positive sample values, and the signal passes through the origin. So let's apply the reflection technique. So first step is that replace n by -n. So because n is there in the signal equation, so we replace n by -n. So we write the reflected version of x of n by y of n. So we say y of n equals to x of -n, and in the equation x of n is equal to n, so x of -n will be minus n. So that means the reflected version y of n will be equal to minus n. Similarly, the second step is to modify the interval. So again, the interval is minus 3 to 3 and independent variable is n. So that means n can have only integer values. So n can be equal to minus 3, then minus 2, but not minus 2.5 and so on, right? So that's clear to you. So you replace n by minus n. So you put minus n here. So you multiply all the 3 by minus 1 to get this thing plus. So when we multiply minus 3 by minus 1, it will become plus 1, and minus n by minus 1, so it will become plus n, and again 3 by minus 1, so it will become negative. As we are multiplying by the minus, so you understand inequalities direction will change. So you will flip this. So in the change modified interval, this will become plus, then you'll write n is less than or equal to plus 3 and n is greater than or equal to minus 3. So after simplification, I get this thing. So the final reflected signal will have the equations like y of n is equal to minus n, and it will have the valid interval of this one. So you understand negative time samples become positive time samples, and positive time samples becomes negative time samples. So as shown here, so you see these are the positive time samples. So they, in the reflected, they become the negative. So negative means they come to after I mean before zero, negative side of this. Okay, it doesn't mean that you reflect these. So for example, this is originally plus 3, so you write minus 3. Now this will not become minus 3. These are the amplitude or signal values, they don't change, only their position changes. So originally they were from 1 to 3, now they will be from minus 1, minus 2, minus 3. Similarly, their amplitude will not change, like this is minus 3, so it will not become plus 3, but their position, index position, will change. So originally they are, this one is at minus 3, now it will become at plus 3, plus 2, plus 1. So hopefully this gives you an idea. If you have any thing to discuss, you can write in the comment section. So that's all for this lecture. To summarize, you studied reflection of discrete time signals. We transformed the sequence step by step. We learned how indices changes after reflection, and we focus on visual understanding instead of memorization. So you understand this course is part of this lecture is part of Signal and System Foundation course with Python. So that's all from my side. See you in the next lecture. Goodbye until then.